Hi guys. So what we're going to look at today is how the exact values that we solved for yesterday relate to something called the unit circle. And what that's going to do is that's going to help us solve for some of the values we haven't been able to find yet. So what we're going to do is we're going to start by looking at some right triangles. All right. We're going to start with the 45, 45, 90 triangle, and we're going to change one thing on it. What we did yesterday when we solved these 45, 45, 90 triangles, we used the same ratio, but instead of using x, we had a 1 in its place. So we used 1, 1, and root 2. Now we can use any values we want to solve that triangle as long as it stays in that ratio. So if we wanted to, we could do 4, 4, 4 root 2, anything along those lines would still work. And it would still give us that value when we simplified in the end. What I want to look at is what would happen if we made the hypotenuse 1. So we're going to make our hypotenuse 1. So what's going to happen here is we're going to solve this equation. So if x root 2 is equal to 1, it means that x is equal to 1 over root 2. So that means both sides of my 45 triangle are 1 over root 2. So I'm just going to fill in that right triangle with those values. Alright, so now let's look at a 30, 60, 90 triangle. Same idea. The other day when we solved that 30, 60, 90, we used 1, root 3, and 2. We're going to use the same ratio, which is x, x root 3, and 2x. But this time, again, we're going to look at this as if the hypotenuse were 1. What is this going to end up being? So I'm going to fill in 1 for my hypotenuse. If 2x is equal to 1, then x is equal to 1/2. So the 30-degree side is 1/2. And that means that the 60-degree side is root 3 over 2. And it's going to be the same on both of these triangles. Across from 60 is root 3 over 2, and across from 30 is 1/2. Okay, so they still fit in the same ratio. Okay, they still fit in the same ratio. So what I want to look at now is I want to take these same triangles, and I want to move these triangles onto what's called the unit circle. So what the unit circle is just a circle where the radius is 1, okay, 1 unit. So any of these lines that we have on here would have a radius of 1. So that would correspond, if I took this triangle, so let's take this blue 45 triangle, if I lay that on top of my circle, that's equivalent to having that radius of 1, that corresponds to the hypotenuse of 1. And these values that are on that triangle, those are the values we just solved for. So if I were trying to find the coordinates of this point up here, then the coordinates of that point would be based off that 1 over root 2 value that I found. Okay, so the point right there in that circle would be 1 over root 2, comma, 1 over root 2. Now let's look in a different quadrant. If I take that 60-degree triangle and I move it over here into the second quadrant, well, I know side to side I've moved a distance of 1/2, and up and down I've moved a distance of root 3 over 2. So that would make the coordinates of that point over there a negative 1/2 because I've moved to the left, and a positive root 3 over 2 for a y value. Now what that corresponds to, that point right there, that would be the same as 120 degrees, or that would be 2 pi over 3 radians. Okay, so now let's look at our 30-degree triangle, and let's move our 30-degree triangle into quadrant 4. And what we're going to do is we're going to find the coordinates of the point right here. And that point would be 330 degrees, which would be 11 pi over 6 radians. And what we're going to do is we're going to find the coordinates of that point. So I've moved a horizontal distance of root 3 over 2, and I've moved down a vertical distance of 1/2. So the coordinates of that point then would be root 3 over 2, comma, negative 1/2. So what we want to look at is how those points correspond to our sine, cosine, and tangent ratios. Okay, so there's a couple ways we could look at this. Let's start with that 60-degree triangle. So first of all, again, we can use any values we wanted to evaluate that exact value. Now what we were used to seeing was if I filled this in as 60, across from 60 was root 3, across from 90 was 2, and across from 30 was 1, and that 1 should be negative. So if I were to try to find the sine of this angle, my opposite over hypotenuse would be root 3 over 2. Well, if I'm going to find the sine on this triangle as well, I'm looking at my opposite over my hypotenuse. I still get that same value of root 3 over 2. So it doesn't matter how I write this, as long as I keep that same ratio, I'm going to get that value. But what I want to look at is what that corresponds to in terms of these coordinates. So that root 3 over 2 was the same thing as my sine. Now let's look at our cosine for both of these triangles. My adjacent over hypotenuse is a negative 1/2. My adjacent right here is a negative 1/2 because I've moved in the negative direction over 1. So that means the x-coordinate at this point is the cosine of that angle. And again, this angle is 2 pi over 3 radians, or 120 degrees. Okay, let's look at how that corresponds to our 30-degree triangle over there at 11 pi over 6 radians. Again, if I were to work this out, if I drew it with a 30 degree, this would be 1, root 3, and 2, which would make this, if I wanted to find the sine, okay, sorry, I forgot this should be a negative 1, forgot my sine. Sine of that angle would be a negative 1/2, which corresponds again to the y-coordinate. Cosine here would be adjacent, which would be root 3 over 2. Or again, looking at the big triangle, root 3 over 2 divided by 1. So the cosine is the x, and the sine is the y. So on your unit circle, okay, the sine of an angle corresponds to the y-coordinate of that point. The cosine corresponds to the x-coordinate. So then we need to figure out what about tangent. What about tangent? So what we can do is we can go back to looking at that triangle. So I want to go back to my 120 degree triangle. If I were to find my tangent ratio, opposite over adjacent, that would be a negative root 3. So I need to see how that corresponds to my two values. And what I can do is I can think about how I would solve that triangle when I had one as a hypotenuse. So from looking at this, my opposite is root 3 over 2, and my adjacent is 1/2. So the way I figure out my tangent values, I do root 3 over 2 divided by 1/2. Sorry, negative 1/2. And when you divide fractions, you flip the second and multiply. So that means I'd be multiplying by negative 2. Those 2's cancel, and I get that same value. Okay, so what I'm going to do to find my tangent is I'm going to divide my y-coordinate divided by the x-coordinate. So tangent is our y divided by our x. It's our y divided by our x. So we can use that information to help us find some patterns for some of these other values. So the first thing I want to look at on here is which functions are positive and negative in which quadrants. If we know that cosine corresponds to the x-coordinate, and we know that sine corresponds to the y-coordinate, we can figure out where cosine is going to be positive and where sine is going to be positive. So if cosine corresponds to the x, cosine would be positive in this top quadrant and in the quadrant right below it. In the other two quadrants, cosine would be negative. If sine corresponds to the y-coordinate, we know at the top two coordinates, sine is going to be positive. And in the bottom two quadrants, sine is going to be negative. And if tangent is y divided by x, well, a positive divided by a positive is a positive. A positive divided by a negative is a negative. And a negative over a negative brings me back to positive. So knowing where it is helps me figure out when these are positive and negative. Now there's also a little way we can remember this. There's a little acronym to help you, and that acronym, it goes in the order of our quadrants. So we start in quadrant 1, and it goes in the order of my quadrants, and that is all smarties take calculus. All smarties take calculus. And what that does is that reminds us which function is positive in each of those quadrants. And then the A stands for all, because everything is positive in quadrant 1. Now this also applies, whatever is true for these functions is true for its reciprocals. So whatever it says about tangent, it also says the same about cotangent. Whatever it says about sine, it also says about cosecant. Whatever it says about cosine, it also says about secant. Now, the last thing that this helps us do, this helps us figure out the sine and cosine values and tangent values for the angles that fall on the line. Okay, those were our quadrantal angles. So, for example, we're talking about values like 0, 2 pi, pi over 2, pi, and 3 pi over 2. So if we want to find the trig values for those, we can't really draw a triangle if it's on the line because it doesn't really have a reference angle. So what we need to do is we think about the coordinates of those points on the unit circle. So for example, at 0 and 2 pi, if I were to plot a point here, the coordinates of that point in a unit circle would be 1, 0. Since we know that cosine corresponds to the x-coordinate, my cosine is 1, and the sine value is 0. Over at pi over 2, coordinates of that point would be 0, 1, the cosine is 0, the sine is 1. Over at pi, those coordinates are -1, 0, cosine, sine. And then down to 3 pi over 2, that's 0, -1, again, cosine, sine. And then if we ever want to get tangent, remember, tangent is our y divided by our x. Tangent is our y divided by our x. So let's just do a couple of these. So let's find the sine of pi over 2. Okay, so the sine of pi over 2 is the angle here at the top. The coordinates at that point would be 0, 1. And sine corresponds to the y. So sine of pi over 2 is 1. 3 pi would be over here. The same thing as 1 pi because I can find a coterminal angle. So those coordinates are -1, 0. And the cosine corresponds to the x. So my answer is -1. Tangent of 2 pi. So 2 pi is over here. Coordinates are 1, 0. And tangent is y divided by x. So 0 divided by 1 is 0. Then tangent of 3 pi over 2. 3 pi over 2 would be located here at the bottom. Coordinates are 0, -1. Tangent is y over x. And if we divide by 0, we can't get an answer. It is undefined. So tangent at 3 pi over 2 is undefined. All right, then when we look at our reciprocals, okay, we need to understand our reciprocals. Let's do the secant of pi over 2. So the reciprocal here, pi over 2, those coordinates would be 0, 1. So my cosine of pi over 2, the cosine of pi over 2 is the x-coordinate, which is 0. So secant is the reciprocal, so 1 divided by 0 is undefined. And then the last one, cotangent of 3 pi over 2. This is a little bit tricky. 3 pi over 2 is down there. The coordinates at that point are 0, -1. Cotangent is the reciprocal of tangent. So if tangent is y divided by x, then cotangent would be x divided by y, which is 0 over -1, which is 0. So that's how we can evaluate our exact values if the functions fall on the line. Okay, how this relates to the unit circle is that your x-coordinates of those points correspond to the cosine, and the y-coordinates of those points correspond to the sine.